Hello guys, you're going to have a couple, 3 videos to watch on top of this one. Kinetic energy, you'll find this in there too. It's a handout we're going to work from. A couple of your homework questions that you'll have, 9 and 10. I'm going to probably give you the answers there because they're math and it's a little complicated. So we're going to work those in class together while they're doing their homework. So I will give you the answers and you can work it to see if you can come up with those answers. But mark those the answers that I put down. That way you'll get those correct. They're not going to be on the test, but just to have an idea of what to do there. Okay, here we go. All right, kinetic energy. All right, what is kinetic energy? Okay, kinetic energy is the energy an object has due to its motion. Okay, remember, kinetic energy is when something is in motion. Okay, so as long as an object is moving at that same velocity, it will maintain the same kinetic energy. Okay, the kinetic energy of an object is calculated, and we talked about this yesterday also, from the velocity and the mass. Okay, that's the 2 things you got to have. As you can see from the equation below, the velocity is squared and can have a significant impact on the kinetic energy. Okay? And here's the equation for calculating kinetic energy. Okay? So it's simple. Kinetic energy equals 1/2, and it's not 1/2 of what? It's 1/2 times the mass of the object times the velocity squared. Okay? And we're going to walk with those 2 problems on your homework. We're going to walk through those together, okay, and kind of help you understand what you're doing. Okay? Those will not be on the test. I'm going to tell you that right now. Okay? Those 2 will not be on the test.
1/2 of
okay?
1/2 of nothing.
It's just 1/2. Just 1/2.
1/2.
1/2. It's of nothing. That's what I just said. The way you calculate it is you just...
It's a number. Like literally the number is 1/2.
We're going to work through it, Julia. Trust me. Okay? I want to show you. Okay? How to measure kinetic energy. The standard unit for kinetic energy is the joule. We talked about that yesterday. The joule is the standard unit for energy in general. You do have other units for energy, which includes the Newton meter, the kilogram meter squared over second squared. You know, we've got all kinds of things, but the general way you would list it is joules. Okay. Now on your homework, that's what he's going to ask you. That's the answer. Okay. The standard unit. I believe we did that. So kinetic energy is a scalar quantity, which means it only has a magnitude. It does not have a direction. Okay? So it is not a vector. Remember, it's got to have both of those things to be a vector. Okay? That's also going to show up on your homework. How is it different than potential energy? Okay? Kinetic energy is due to an object's motion, while potential energy is due to an object's position or state. Okay? When you calculate an object's kinetic energy, its velocity is an important factor. Velocity, however, has nothing to do with the object's potential energy, because if it has potential energy, it's not really moving, so it has no velocity, right? Okay? Now, it shows you there in that little picture, the lighter colored ball is supposed to be green, and the other one apparently was purple. Okay? The green ball has potential energy due to its height. You notice they've got it like it's sitting on a shelf. Okay? The purple ball, the one on the right, is falling. That's what the lines represent. It's falling. So it has kinetic energy due to its velocity. Okay? It's falling, so it has velocity, so therefore it has kinetic energy.
Is kinetic energy only used whenever it's moving?
When it's moving. That's what kinetic energy is. Kinetic energy is when something is in motion. Yep. Yes, sir.
But if you were to throw the ball up, it would only be potential energy for the split second when it stops.
Exactly. Exactly. At that point in time, it is, as it's going up, in fact, we're going to talk about that right now, talk about a roller coaster here. That's a great point. One way to think about potential and kinetic energy is to think about a roller coaster, okay? You're sitting in a car on a roller coaster on the track, and as the car travels up the roller coaster, as it starts up that big hill here, it's got kinetic energy, but it's gaining potential energy. Okay? It is gaining potential energy, but it's using kinetic energy because it's in motion. When it gets up to the top, it's getting ready to crest. That's potential energy just for that split second. Why it tops up there and it almost comes to a stop. Well, actually, it does most time it kind of come to a stop before it falls down off. That has stored up, but that now it's potential energy. Now, once it takes off back down that hill, now it's using kinetic energy again, and it's losing potential energy because it's picking up velocity as it goes down the hill. So as it goes uphill, it's using kinetic energy, but it's gaining potential. Once it gets to the crest, it has potential energy. Once it starts back down again, it's using kinetic energy, and it's losing potential energy at that point in time because it's going downhill. Okay? Think about a pendulum on a clock. Okay? It swings back and forth. When does it have potential energy?
When
When it's at right where your hand was.
You think it's when it's at the top?
Yeah.
How about anywhere else?
On the other side.
On the other side. That's potential energy because just for that split, a blink of an eye, it becomes still. And then it starts again. Yeah.
Yeah, it's only a split
And
second.
and as it goes up, it's gaining that potential energy.
But then as it goes back
And then as it comes down, it's losing potential energy. Yeah, exactly. Okay? All right. Some example problems is a car and a bicycle are traveling at the same speed. Which has the most kinetic energy? What do you think?
The car does. What is it? Yeah, car.
Yeah, the car does.
Because it has more mass.
Because it's got more mass. It weighs more than the bicycle. Well, we talked about yesterday, if you got hit, if you were crossing the street and you got hit by a guy on a bicycle going 20 miles an hour, or you got hit by a bus going 20 miles an hour, the bus is going to do a whole lot more damage because it's got a whole lot more mass. Okay? So the idea is look both ways and don't walk out in front of either one of those. Okay? So a ball weighs around 1 kilogram and is traveling 20 meters per second. What is the kinetic energy? Okay? So what you have to do there, this is where you would take the 1/2 times 1,
Which is 1/2.
which would be 1/2, and then
You times it by 20.
By 20.
squared.
okay?
So
Okay.
you would have to do each one by 20, so that would be 20 over 40.
Yep. There you go.
And you.
No, it'd be 1/2